All right, to continue our discussion, where again you choose a point that's between the two zeros, so the number that's between 0 and 2 is 1. You have to choose dead in the middle. Take the 1 and plug it in. So when I plug in g of 1, again, this is that part where you're looking for more points to be more accurate. If I plug in a 1, what do I get? Which is -1. Good. So if I plug a 1 into my function, I get a -1. That tells me that tells me that when I get to -1 on the graph, I'm going to have a point at 1 comma -1. That will be your extrema. That means that will be either a maximum or a minimum. So therefore, I'll go to that value and then start traveling back through it. So there is your graph at its accurate form. Not bad? All right. Everyone got it? All right, let's try another one then. Give you an opportunity to write this down. So some of our work is already done, which is great. True, in a sense. You're onto something there. Yeah, to the third power, yes, sir. All right, ready? So we have to. What's step 1? Find the end behavior by looking at the leading term. This is not multiplied; it's actually factored. So what I have to do is let's calculate our n, which means I have to figure out what's my largest exponent. So I have a 3, a 2. Would I consider a 1 right here? No. Why? Because it has no x. We just want to know what the highest exponent is going to be for our x value. So I'll have an x squared and an x cubed. Added together will give me what? X to the 5th. So if I was to have to fold this completely out, I would eventually get something with an x to the 5 or x to the 5th. This is how you would say it. All right. So 5, is it odd or even? Odd. Okay. Now we want to determine if it's going to be a positive or a negative number. All right. So I see I have a positive number there. This is a positive number there. And this is a positive number there. So if I take 3 positives together, I'm going to get what? Positive. So I got an odd positive. Okay. So how does my end behavior look with an odd positive? Same as the last one, right? It's going to start from the bottom and then finish on the top. Right? So again, I'm going to go ahead and I'm going to add my little arrows so I know where I'm supposed to start and stop. Step 2 was plug in the 0 for x. All right, so if I plug in 0, I get 0 minus 3. So I'll do it like this. So I'll do 0.1. I can't do anything with that. So I'll get 0 minus 3, which is good, -3 squared, which gives you 9. Perfect. And then if I plug in 0, 0 plus 1 is 1. And then 1 cubed is just what? 1. So then my real question is, what's 0.1 times 9? 0.9 times 1, 0.9. All right, so that means I have a y-intercept at 0.9. So here's 1. I guess I'll have a decimal, or not a decimal, but a point. There we go. Somewhere about right there. Right? Doesn't have to be completely dead on accurate. All right, what was step 3 then? Factor to find the x-intercepts. Now all of this is already factored, so all I gotta do is set each factor to 0. Each factor equal to 0. Now, would I set 0.1 equal to 0? No, because it's not gonna do anything. It's not real. So then I would take the rest of my factors. So then I take x minus 3, set equal to 0. That means x equals what? 3. With a multiplicity of what? Very good. Then I'm going to take x plus 1, and I get x equals negative 1 with a multiplicity of 3. Very good. All right, so I think in that step 4, we then plot those points. So let me go ahead and plot them. So I got something at 3. So 1, 2, 3. So I'm going to put a point right there. I then have a point at negative 1. So I'll put a point right there. Okay. All right, what was step 4 or 5 or whatever? All right, so we got the multiplicities in there, and then the next step was like actually sketching it, right? So let's find our extrema. So I have 2 zeros. What number is dead in the middle between negative 1 and 3? Yes, 1. So what we need to do is we need to go find out what is m of 1. Because that will be where my extrema will happen at. So I have basically, just like last time, I have 0.1 times, what's 1 minus 3? Negative 2 squared, 4. So I have a 4. 1 plus 1, 2. 2 cubed, 8. I think it'll actually be easier to do 4 times 8 first, which is 32, and then 32 times 0.1, 3.2. All right, so that means at 1, I will go up to 3.2. So that's 2, 3, put a 4 there. So 3.2 is about right there, right? So that should be where my max happens. All right, so now I can sketch it. When I get to, what's that value? Negative 1. What's the multiplicity? 3, even or odd? Odd. So since it's odd, I will go through it. So odd, I'll go through it. So that means I'll come over here, I'll go up, and I'll hit it. And then I go through the y-intercept, and be a little bit better accuracy here. I'll eventually go up here, and then I'm traveling towards the next 0, right? I won't count off for your artistic ability. All right, so then I get towards 3. What's my multiplicity? 2. So is it even or odd? Even. So if it's even, what will I do? I will just touch it. So when I get to 3, I'll hit it. I'll hit it. Come on now. I'll hit it, and then just bounce back up to my end behavior. And there you go. And that's it. And that's all you do in 3.2. So now let's jump into 3.4. All right, so in section 3.4, we're talking about zeros of polynomials. Yes, we're finally on Wednesday. The first objective is applying the rational zero theorem. I hope. We need to. Are you ready? All right, so obviously you can see I'm at the end of my PowerPoint, so I'm going to switch softwares, okay, so that it could still be recording. And maybe this might be a better way. Who knows? Okay, so it should still be sharing the screen. All right, there we go. So this is what you need to know. So again, we're in objective one applying the rational zero theorem. Here's your rational zero theorem. Maybe not. Oh, guess it helps to select the pen. All right, so again, here's my rational theorem. So rational zero theorem. Basically like this. You will take P divided by Q, and what we're trying to do is we're trying to find possible zeros. Your P will represent the factors of the constant. The Q will represent the factors of the leading term. The number without the letter. The constant is the number without a letter. It's that last number at the end. So that's basically what the rational zero theorem states. To get possible zeros, we can take all the factors of the constant divided by the factors of the leading term. Okay, so that will start off this process. Okay, we'll come to that a little bit. So let's do an example. So right now, in example one, I just want to find possible rational zeros. So find possible rational zeros. All right, and the example we're going to look at is going to be k of x equals 25x to the 7th power plus 22x to the 4th power minus 3x squared plus 10. All right, so the only thing I care about is just the constant, which is the last number, and the leading coefficient, which is the first number. So what I have to do is I have to determine all of my factors of 10. So here we go. So again, this is P, which is not how you write a P, divided by Q. Okay, So I'm going to take my factors of my 10. This is the way I like to do it. Here's also another thing you need to think about. We don't know if it's a positive or negative. So what we're going to do is we're going to say plus or minus 10. Easiest factor. Well, maybe that's not the best route. Yeah, that's what I'm thinking. It might be easier to start at the 1. Is there an eraser to this? Eraser. Nope, but there's an undo button. Undo, undo. All right, we'll start with 1. All right, so we'll start off with 1. And then we go, all right, does 2 go into 10? Yes, so that's plus or minus 2. Does 3 go into 10? 4? 5? Yes. So that's plus or minus 5. 6, 7, 8, 9, 10. Yes. And we can stop there because that's the largest number. So those are all the factors. That's 1, 2, 3. That's 8 options just on the numerator. So now let's look at our options on the denominator. I got to do all of my factors of 25. Does 1 go into it? Yes, so plus or minus 1. Does 2, 3, 4, 5? Yes. So plus or minus 5. 6? Nope. 8? I got 5. I think so, yeah. So it doesn't go into 6, 7, 8, 9. Doesn't go into 10, 11, 12, 13, 14. Doesn't go into 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then we're back up to 25. Right? So I have 6 numbers on the denominator. Now this is where it gets really fun. You have to take this guy, divide all of those numbers. Then we're going to take that guy and divide all of those numbers. Then we're going to take this guy and divide all the numbers, and we're not going to repeat any numbers. Ready for the fun? 1 divided by 1. So we have plus or minus 1 as an option. 2 divided by 1. 2. So we have plus or minus 2. 5 divided by 1. 5. Good. So that's plus or minus 5. 10 divided by 1. 10. So that's plus or minus 10. Okay. Now we move on to 5. 1 divided by 5. 1/5. So we have plus or minus 1/5. And then we have 2/5. So plus or minus 2/5. Well, 5 divided by 5 is what? 1, which we already wrote down. 10 divided by 5 is, which we already wrote down. So then we move on to the next one. 1 divided by 25. Good, so we get plus or minus 1 over 25. 2 over 25. So we got 2 divided by 25 plus or minus. And then we have 5 over 25, which reduces down to what? 1/5, which we already wrote down. And then 10 over 25 reduces down to 2/5, which we already wrote down. All right. So that means in this question, if you had to find out all your zeros, you have 1, 2, 3, 4, 5, 6, 7, 8, 16 different numbers that could be a 0 or none of them. That's where it gets fun. But that's what the rational zero theorem states for us. All right, so this is where I disagree on skipping 3.3, but I'll teach it to you anyways because y'all said you're really good at it. Okay. All right, here we go. Let's move on to another slide. What time is it? What time do we get out? Okay, we got 2 minutes, and there's no way I can do this problem in 2 minutes. So we're going to stop the recording there. That means that 3.1, 3.2 due Sunday, 3.4 and 3.5 have now been moved to Tuesday. Okay, so that's what 24 total questions due on Sunday.